that happened with t-testing before. I never had you actually finish the t-test statistic calculation. We got it, we understood why it had to be there, the technology does it for us. You're about to see why. You're about to see why. Okay, so, what you're looking at right now, are two independent samples of values. These are not my break distances. They're just random numbers I'm picking. And the logic applies both to my random numbers and also to my break distance and also to any other two samples. So right here, we have random numbers generated between 0 and 50. And the blue is random numbers generated between 50 and 100. So I've split the numbers from 1 to 100, or 0 to 100, I guess, into two halves. One of them, the yellow bars, are going to randomly pick numbers between 0 and 50. The blue bars randomly pick numbers between 51 and 100. Okay? So every time I press F9, it picks more random numbers, just like you guys did back in 243. Boom, 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 boom. Little shimmy, little dance, little shake, little shimmy, little shake. All's good, all's good. Make sense so far? Now please notice, and just take a quick look up here. The average of the first set of numbers is 25. I hope that makes sense if you're picking between 0 and 50. The average should be 25, right in the middle. Hope that makes sense. The average of the second set of numbers should be 75, between 50 and 100. Notice how that average pretty much stays exactly where it is. I forget how many I'm selecting. I think I'm selecting like 1,000 or something. Yeah, something like that. So it's a bunch of them. It's a bunch of them. Okay, so the average is 20, the average is 75. The variance, this is an interesting little quantity that you might or might not remember. Remember what the variance is? You can say no if you don't. It's totally fine if you don't. It's the square of the standard deviation. So in other words, these guys over here, these sample standard deviations, the S's, that's sample standard deviation. If you squared that per Veronica's request earlier, you get what's called the sample variance. I bring this up because of one thing we'll talk about in a moment. Okay, notice how they're staying right around 208. 208, they're staying pretty consistent as these numbers switch. Now what I've then done is, I've decided to look at how can I combine these two independent groups of values. So what I did was, I first took the smaller numbers and subtracted from them the larger numbers. Now I want you to understand something. That means I took one of these groups of numbers here, the small yellow ones, took that, whatever value that is, and subtracted one of the bigger ones. Now hopefully you're going to understand that's going to be a negative number, because you got a small number minus a big one. Even if the yellow one is 50, and the blue one is 51, 50 minus 51 is still negative. If the small one is 0, and the big one's 100, 0 minus 100 is negative 100, but it's still negative. The question I have is, on average, what is it going to be? Well, hopefully, you see that it's negative 50. Because on average, the small one's 25, the big one's 75, 25 minus 75 is negative 50. Hopefully you guys buy that logic. Is that believable? I can prove it to you mathematically. I don't think you want to see it. It's on the website if you want to see it. It's all worked out for you. So on average, the average difference is negative 50. If I subtract them the other way, does that make sense that the average should be positive 50? Hopefully. Because that's bigger minus smaller, so 75 minus 25. And then last but not least, I figure, what the hell, what if I add them together? x2 plus x1. And that's going to be 101. 101, again, because of the rounding, there's some decimal points going on in there. Because it's 0 to 100, there's actually 101 values in there. Okay, so notice, those are staying pretty consistent. What I want you to focus on right now, this green one right here is what we just did in our experiment. We did the cantilevers minus the V's. So, everybody buying the average? Why is it negative 50? Hopefully that makes sense. 25 minus 7. Well, that's a 76, so that's just because of the random fluctuation in the data. How about over here? How is this variance related? How's that variance related to this guy, these guys?
No, added.
Say that again.
Added.
It's added. So remember what I asked you guys about what standard deviation should we use? We actually don't subtract them. We add them. What the hell? Look at the graph. Look at the graph, the green graph in the back. That 417 variance stretches all the way from here, all the way to here. Do you see how that big green graph takes up both data sets? Why is that? Well, there's two answers for that. There's a quick answer and there's a long answer. The quick answer is, imagine taking two separate measurements. You're going to be off on both of them, aren't you? You're going to be off a little bit on both of them, just like me and Max. So if you have error in both measurements, variation in both measurements, and you put those measurements together, hasn't your error been compounded? You screwed up a little bit here and a little bit here, that means you screwed up basically twice as much, assuming you screwed up the same amount. Hopefully that makes sense. You can't subtract the error, that makes it seem like you're more precise than you should be. That's the quick and easy answer. There's also a mathematical one which you can read online if you want to. I got it posted to the website. So basically, this numerically shows you what logic tells you. If you take a measurement yellow and you take a measurement blue, and you put those together, you have to add the errors. So, we're going to shut this guy down. We're going to do it right now. And I think we now have an answer. And again, I would never ask you to compute this manually. I just want you to understand why it is what it is. We now know what has to go down here. What we have to do is add those two variances together. So x1 definitely has a variance. It's s1 squared divided by root n1. That's the variance. Excuse me, divided by n1, not root n1. And the second is s2 squared divided by n2, and you square root all of that. That's how you decide how many standard deviations with 2. Sorry, Danielle. And like your face changed when I write illegibly. That tells me to. This is not the kind of formula I want you to memorize. It is the kind of formula I want you to know. This is what technology is going to vomit out at you. When you go to your TIs in a minute and we run the test for this bad boy, this is what it's going to kick out at you. This is what it's going to kick out at you. So all these numbers you have from your original data. S1 squared, that would be 2.1 feet squared. Divided by N1, that would be 21. So that divided by 21, plus S2 squared is 1.1 squared, 1.21 square feet. Divided by 20, add those together, take the square root.
Where's the 20 from?
That's from the sample sizes we had originally. Remember, we had 21 from the cantilevers and 20 from the V-brakes. So it's the sample size. It's how many data points are in each sample. But your question is gorgeous. Danielle has given us this, very quick to get, 7. This is a little more tedious to construct, isn't it? It's a little more tedious to construct. And then when you're done with it, you have to divide it into this. And then you're not even done at that point, if you're doing it by hand. Because then you have to figure out which t-curve you're going to be on. Remember, t-curves are all different. So that's why we stop here as far as doing crap by hand. And we start referring to technology. But I needed you to understand why that is the case. That's the stick. That's the measurement stick. That's what you have to do as far as understanding how far out 7 goes. And then we're going to pause, because I forgot these guys were coming. They are a part of a psych class,
Yes.
sociology class, I forget now, Angie.
Biological psychology.
Biological! That was kind of wrong on all counts.
Or
They're going to talk to you
physiological
real quick
psychology.
about a study they're doing, then we're going to regroup and we're going to do this, we're going to run this bad boy in our machines.